Newton's first law of motion. Bro, I've just seen a video of this. I think it's about the Newton's first law of motion. But I don't understand how that works. Can you explain it to me?
Yeah, of course. Harishven, right, from class?
Yeah, Mitvesh.
Yeah. Okay. So basically, Newton's first law states that an object at stationary or in uniform motion will stay in the type of state unless it is acted on by an external force. So there are two different states that it could be, either in uniform motion or stationary.
Oh, that means that object is not moving at all. Not exactly. It's like in a particular position, it will only be in that position unless it is acted by another force, which is the external force, right?
Yeah, exactly.
I see. That's fascinating, right? Seems like I'm getting a rough idea about the Newton's first law of motion. So, let's go.
Okay, now that we've defined what Newton's first law is, let's take a look on what it explains. So, we know that a moving object requires a force to keep it moving, either a pushing force or a pulling force. So, when an object is acted on by a resultant force, the object will have a certain velocity. So, now some objects have a constant velocity, which means they move at the same speed constantly. So, this can happen in two ways. One, where the object is stationary, which it has a constant velocity of 0, or it's moving with uniform velocity, where it has an acceleration of 0.
Alright, now we have seen the Newton's first law of motion. Now, let's move into the law of inertia. So what are the relation between the Newton's first law of motion and the law of inertia? Well, it's pretty much the same. So, what is inertia? Inertia is an object's tendency to resist a change in motion. Now, when we are talking about resist a change in motion, it has to be in the motion. Well, in this case, we have two different examples. So one is an object in a uniform motion, right? Another one is object in a stationary motion. Not a motion, but it's the object is at the rest. Okay, so that is the two different motion where object have the tendency to resist a change, which means it doesn't want to move, in easy words. Okay, now we are going to see that what are the influencing factor of inertia. So as you can see, this is one Jenga block and we have a planet of Jenga blocks. So now see what happens when I try to push this one Jenga block and this lot of Jenga blocks. I'm just using my one finger. It's easy though. But what happens when I use my one finger to pull this box full of all Jenga blocks? It's kinda hard. Okay, so now we can see that one of the influencing factor of inertia is the mass. This is a lower mass and this is higher mass. So what is the connection between mass and inertia? As mass gets greater mass, greater inertia.
Okay, so now we are going to look at a demonstration of inertia using a example that you can find in daily life. So as you can see, I've placed a couple of Jenga blocks here. So watch what happens when I swipe very quickly from the bottom with another Jenga block. As you can see, the blocks that were on top stayed on top because the inertia of the blocks on top kept them on top even though the bottom ones moved. Instead of moving like all together at once, the inertia kept it in its place. Okay, moving on, let's watch this video about another example of inertia in our daily lives. Okay, now that you've seen the video, as you can see, the badminton racket was stationary along with the dirt that was displaced on top of the racket. So when the ball hit the racket at a large speed, at a very high speed, the racket moved downwards very suddenly. So the dirt, which was on the badminton racket, which was stationary, the inertia of the dirt will keep it stationary in place while the badminton racket moves downwards. That explains the video you've just seen. Okay, so when a car brakes suddenly while it is moving, the passenger will get thrown forwards. This is because the inertia of the passenger tends to keep the passenger moving while together with the car. So when the car suddenly stops, the passenger also gets thrown forwards. Just like that.
Okay, now we are going to see the opposite what we saw just now. So now the car is in a stationary position, and when the car is about to move, we will have the different movement of what we saw just now. So literally I'm just sitting here and we just wait for the traffic light. Camera zoom. Okay, now we see that I tend to move forward. This is because of the inertia that is keeping me to be in my stationary position where I was just now. So remember, sit back first. Alright, in the previous video we just saw just now, we have plenty of water droplets on top of the umbrella. So now what happens when I just tap the umbrella, we can see that water droplets flew away. So this shows inertia, which is why the water has a tendency to remain at its current position or resist any change in motion. So when I spin the umbrella, the water droplets tend to resist the motion, which is why it flew away from the umbrella.
Okay, now moving on, let's look at yet one another example of inertia in our daily lives. Now, on this table here, I have a stack of books. So now, watch what happens when I move the cloth slowly. You see how the books fell together with the tablecloth. Now, watch what happens if I pull the tablecloth extremely quickly. Watch what happens. Voila! You see how the books stay on the table even though I pulled the tablecloth. So, how does this work? So, basically, the inertia of the books, which causes it to resist the change in motion, resisted the motion in which I pulled the tablecloth. Since I pulled the tablecloth at a very fast speed, the inertia of the books kept it on the table, which is why it stayed on the table.
Alright, next we are going to see another example of application of inertia in our daily lives. So now I'm going to use the chili sauce bottle and I'm going to demonstrate how inertia works on this chili sauce bottle. So I'm pouring this. Okay, so what we observed just now was when I tried to pour the chili sauce on the plate, as you can see here, it flows according to the motion of the slope of the chili sauce bottle. But what happens when I suddenly stop? It was in this condition and I suddenly stop, but the chili sauce tend to flow. It is because of the effect of inertia, where its tendency to resist the change of motion of the flow of the chili sauce. So that's how inertia works on a chili sauce bottle. Pretty easy though.
That's so hard.
Well, look what I got. What do you get?
I was trying to cut out the tree, but it's too hard. I couldn't.
That's because of mass. This plant has a smaller mass, so the inertia is small. This tree is a very big tree, and of course the mass is big, so the inertia is high.
Oh, that makes sense.
Yeah. So basically, the law of inertia and also the law of Newton's first law of motion. Yeah. It's kind of easy though. It's not that hard.
Yeah, it's not too complicated. It's just nice.
Yeah. Both of the law very specifically explains each and every term, and it is very obvious in our daily life, isn't it?
Yeah, we can see it so many times in our daily life. Many examples that we can learn from.
Yeah, true. So, I already got a very good idea about what is Newton's first law of motion as well as law of inertia.
That's great.
What about you guys?
So guys, that was our presentation on inertia and Newton's first law. Hope you guys understood everything that we taught. Oh yeah, like and subscribe.